welcome to this afternoon's live intermediate lesson, okay? What I'd like you to do, we're doing probability trees this afternoon, okay? Have a go at the challenge grid in front of you. You'll need to pause the video. All of these topics are topics you'll find in intermediate, okay? It's worth, if you actually took this from a paper, it's worth about 30 plus marks, okay? So it's a big chunk, huge chunk of the two papers, okay? Pause the video now and have a go. Right guys, you should be all done, okay? So what I'm going to do, I'm going to go through each one individually, okay? Okay, I'm going to go through each one individually. First one worth 2 marks, we're going to add 12 to both sides. So I've got 6x moves straight down. Plus 12 minus 12 is nothing. 48 plus 12 is 60. And then if I divide by 6, I end up with x equals 10. First one done, very straightforward solving equations. Next I've got 0.3 times 0.7. I can't do that, so I'm going to do 3 times 7, which gives me 21. But I can, if I look back at the question now, it's 0.3 and 0.7. Because there's two numbers after the decimal point, I've got to go to my answer, count back 1, 2, and put a decimal point in. 0.21. 1 mark. Okay, bit of trigonometry now. Okay, so it's quite early on in the challenge grid, but it's important you get good at this, okay? If you're going to succeed at intermediate or higher tier, you've got to get good at trigonometry, okay? If we label our sides, we've got opposite, hypotenuse, and adjacent. Okay, if I do SOHCAHTOA, okay, and I get rid of the one I don't need A, because A hasn't got a letter or a number attached. Hypotenuse has got 5, opposite has got x, A hasn't got anything, so I'm going to cross it out. So I'm going to be using SO. I'm going to draw out my SO triangle, S, O, and H, times in the middle. Now, O is the bit I need, so what you should do is take your thumb and cover O in your triangle with your thumb. O equals, you're left with sin times by H. So we've got sin 37 times by H, which is 5. If I put all that in my calculator, I end up with 3.01 centimeters for x, okay, which makes sense. 3 marks for that one. Very easy topic, just you've got to practice it and you've got to learn how to do it, but it's repeatable. It's the same thing every time. Okay, so factorize and solve. This is a difficult one, comes towards the end of intermediate. Okay, I've got to factorize this into 2 brackets that are going to equal 0. I've got to find 2 numbers. They've got to multiply to make negative 12 and add to make positive 7. Okay, so it's going to be x and x. The 2 numbers I'm thinking of are 4 and 3. Because they add to make 7. They're going to both have to be negative if they're going to times to make, add to make, if they're going to, okay, I've written this one out wrong. It should be, yeah, I've written this one out wrong. It should be positive 12. Okay, if it's positive 12, then it will be plus 3 and plus 4. Okay, I've written the question wrong, apologies for that. So x plus 4 and x plus 3, okay. We need the opposite of those to solve for 0. Okay, so x would have to be minus 4 or minus 3. Okay, apologies for writing the question wrong there. That's worth 3 points. Next one, I got 12x to the power of 8 divided by 2x to the power of 3. Take your front numbers, divide them normally. 12 divided by 2 just gives me 6. And then what you do with dividing with indices, you subtract your powers. So it's x, 8 take away 3 gives me 5. So my answer is 6x to the power of 5. Next one, I got 3 over 7 take away 1 over 3. Okay, times the 2 bottom numbers. 7 times 3 is 21. Okay, 3 times 3 is 9. 7 times 1 is 7. 9 take away 7 is 2. If there's 21 on the bottom in the question, there's got to be 21 on the bottom in the answer. Taking away fractions should be very straightforward for you now. 25% of 180. Okay, a couple of ways of doing this. Okay, you can find 10% first, which is a very repeatable way, or you can just half it and half it again. I like finding 10% first only because it makes it exactly the same question every single time. 10% is 18. 20% would have to be double that, which is 36. 5% would be half of 10, which is 9. If I add the 2 bottom ones up, I get 25% equals 45. Really easy. Next, a bit of simultaneous equations. Okay, got to make the y's the same. Okay, they're different at the moment. I'm going to times the top one by 3 and the bottom one by 2. That'll make them both into a 6. I have a 9x plus 9y. Oh, no, sorry. My mistake. 9x plus 6y equals 48. Okay, and then the bottom one times by 2, 8x minus 6y equals 20. Now don't make a mistake like I just did and just forget to times one of the things by the right amount. Okay, it's very easy to do. Okay, so I'm going to add them together to make the y's disappear. 9 plus 8 gives you 17. 17x. Add the two middle bits together. That'll give you nothing. 17x, add the two end bits together. Okay, you end up with 17x equals 68. Okay, and then if you divide through by 17, you should end up with x equals 4. X equals 4 for the first one. Once you know x equals 4, you can substitute that back in. 3 times 4 plus 2y equals 16. You can see I've used equation 1. Okay, 12 plus 2y equals 16. Take away 12 from both sides, you end up with 2y equals 4. That means y has to be 2. Okay, really straightforward, 3 points. Now, last one, nth term, look what it's going up in. It's going up in 1, so we're going to have 1n. Whatever comes before the first number goes on the end. Okay, so my answer is going to be 1n plus 2. Okay, very straightforward. You look at your jumps and you look what comes before the first number. Right guys, pause the video now, mark that. Make sure you add up your scores. Okay, 15 or better is really, really good. If you're getting higher than that, you probably don't belong in intermediate anyway. So, just the basics of probability now. We're going to go through probability all the way through, but I just want to go through the basics. Now, these helpful hints on the right-hand side are really important. Probability has to add to 1. Okay, has to, whatever happens. So you'll find all of these numbers in here, they all add to the number 1. Okay? Now, if you want the probability of something or something happening, either or, you have to add those two probabilities together. If you want the probability of something and something happening, one after the other, you've got to multiply. So the first one, what is the probability that the card is labelled east or south? East is 0.25. It's the or rule, so we'll be using this one. South is 0.2. If I add those two together, my answer is 0.45. It's literally that simple probability. Okay, what's the probability they choose a card? They both choose a card. So someone, Kerry and Sasha, choose a card labelled north. That's this rule down here. It's going to be 0.4. Sasha's choosing it as well, so it's times 0.4 gives you 0.16. Okay, probability is literally that straightforward. Most of the time with tree diagrams, we're going to be using the AND rule. Right, so this is what a tree diagram looks like. Essentially, the only thing you really need to know is they all add to 1, the rules in the helpful hints box, and each branch adds to 1. Okay, so not everything in the diagram doesn't add to 1, but each branch that's connected, like the ones I've drawn in red by there, adds to 1. So 1 over 5, the one with red in by here, and the bit yellow box underneath will both add to 1. So 1 over 5, so that would mean yellow has to be 4 over 5. Okay, really straightforward. Okay, so player picks a ball random from each bag. Okay, they're picking from 2 bags. Player picks 1 ball. We're assuming they're putting it back because they haven't said otherwise. Okay, so if it's going to be red and yellow on this one, okay, bag B has got 2 red balls and 1 yellow ball. So if the probability of picking a red is going to be 2 out of a possible 3. So the 1 yellow ball is going to be 1 out of a possible 3. And it's going to be the same thing down here, 2 out of a possible 3 and 1 out of a possible 3. I've got that from the information about bag B. Once we're there, they've got a question down the bottom right. Find the probability of picking 1 ball of each colour. Okay, 1 ball of each colour is going to be two different ways of doing that. You could either get 1 red and then 1 yellow, which is 1 over 5 times 1 over 3. If you're working out the probability using tree diagrams, it's a times question. Probability of picking a red and a yellow. 1 over 5 times 1 over 3 is 1 over 15. Or you could go for 1 yellow and you could pick 1 red. So the probability of picking a yellow first and a red, 4 over 5, a yellow from bag A and a red from bag B. Oh no, it's not add, it's times. Probability of picking a yellow from bag A is 4 over 5. And a red from bag B is 2 over 3. 4 times 2 is 8. 5 times 3 is 15. Now, they want to know the probability of picking 1 of each colour. Okay, it's those two, the two that I've just worked out, added together. because you could either pick a red and a yellow, which is this one, or you could pick a yellow then a red, which is the second one. Okay, so I'm going to add them together. 8 over 15 plus 1 over 15 gives me a probability of 9 over 15 as an answer. Okay, quite straightforward to start us off. What I would do, if you want to copy any of these down, pause the video now and get them copied down. Next one. Okay, Andrea sometimes needs to get a lift from college. Okay, this is another straightforward one, and I'm going to help you through it. If you want to pause it and have a go yourself, you're welcome to. Okay, if you think you can do them, but I'm going to go through this one now. So Andrea sometimes gets a lift to and from college. When she does not get a lift, she walks. The probability she gets a lift to college is 0.3. Okay, this is all done by here. So if it's 0.3, she gets a lift to college. The probability she walks to college on the first bit is 0.7 because it's got to add to 1. Over here now, probability Andrea gets the lift home from college is empty, but the probability she walks home from college is 0.6, so that will be after 0.4. They're independent events, so it's going to be repeat themselves, it's going to be 0.4 and 0.6 again, because all the ones down here are the same. You can see on the right hand side that they're exactly the same written down. Okay, so 2 questions. Calculate the probability she gets a lift to college and then walks home from college. So probability she gets a lift is 0.3. Probability she walks home is 0.6. So if they want to know those two, probability of getting a lift and walking home, is going to be multiplied 0.3. 0.3. Go on, pen. 0.3 0.3 times 0.6 gives you 0.18 for the first one. Okay, we're timesing, it's an AND rule, so we're timesing them together. On part C, calculate the probability that Andrew does not get a lift to or from college. So the only way she doesn't get a lift to or from college is if she walks on the first day and then walks on the second day. So the probability she walks on the first day is 0.7. Probability she walks on the way home is 0.6. Probability of those two times together is 0.42. Very, very straightforward questions, probability trees. Okay, there'll always be 2 questions attached. Normally they're worth about 6 marks. Loads of marks for this. Right then, so again, another probability trees question. We'll do 2 more. So, probability that Eva buys a sandwich for lunch is 0.6, sorry. So that's done for us down by here, you can see. So that means this one by here, I'm going to fill it in straight away, has got to be 0.4. I'm not going to fill this one in yet though. Okay, there's a trick to this one. So the probability that Eva buys a sandwich and a drink for lunch is 0.18. So buys a sandwich and a drink is 0.18. Remember the AND rule by here, and a drink is 0.18. So what they're trying to say by here, the probability that he buys a drink for lunch is what we want to work out, what's in my red circle. They're saying the probability he buys a sandwich, which is 0.6. Probability he buys a drink, which we don't know. If you times those two together, because it's the AND rule, it gives you an answer of 0.18. So we got to work out what goes in that gap. 0.6 times something makes 0.18. 6 times 3 makes 18. So that's got to be 0.3. So the probability he buys a drink has got to be 0.3. Because 0.6 times 0.3 would have to give you 0.18. Okay, once I've filled that in, 0.3, that means the one underneath has to be 0.7. Underneath that, it's just going to repeat 0.3, 0.7. On part B, so that's that one done. Okay, probability he buys a drink up by here is 0.3. On part B, find the probability he does not buy a sandwich and does not buy a drink. So probability he doesn't buy a sandwich is 0.4. Probability he doesn't buy a drink is 0.7. If they want to know the AND rule again, 0.4 times 0.7 gives me 0.28. It is literally that simple. Okay? Most of the time it's AND rule with doing probability trees. Again, guys, if you ever want to do one yourself, just pause it before I start. Right, guys. Pause the video by here. Terrible hay fever. Pause the video by here. Have a go at this for me, please. And then once you're done, I'll go through it. Right, guys. So All the members of a farming club visited the Royal Welsh Agricultural Show. A lot of reading by there. It doesn't actually matter too much to us. So we know these two. Pen. We know these two. This one and this one add up to 1. So that has got to be 0.13 in order to add it to 1 by 0.87. This would be a calculator question, I think. And this one add up to 1. So that would have to be 1 over 3. Down the bottom there's one question attached. Complete the tree diagram is always worth 2 marks. Okay, we've done it already. You just got to fill in the missing branches. What is the probability the member chosen at random was not one of those who travelled by bus on the first day of the show? So probability someone chose at random didn't go by bus on the first day of the show. Okay. The way to do this is kind of a trick question. They want to know the probability that someone didn't do bus and then first day. They want to know the probability that someone didn't do these two things. So in order to do that, we know if we worked out every single option on this, it would all add up to the number 1. If I want to know the probability that someone wasn't one of those people, I would do 1, take away the probability that someone was one of those people. So I'm going to do 1, take away. First I'm going to work out what the probability someone went bus on the first day. So 0.87 on my calculator times by 2 over 3 is the probability of someone who went on a bus. Okay, that would be 0.87 times 2 over 3. Gives me 0.58. That's the probability someone went on a bus on the first day. We don't want that. We want the probability of everything else. So we're going to do 1 take away 0.58. Which gives me 0.42. Okay, that's a little bit of a trick question right there. But the rest of them are fairly straightforward. Guys, if you found this video